Okay, hello everyone. We're starting a little later than expected. This will probably not run very long. We are looking at some language completeness and consistency items. We're starting with system exception.
Right. We started to talk about this last time and, ran out of time. And, this is somewhat orthogonal to the discussion of, exceptions that we had on Monday. So, right, there's this thing called system exception, which has existed for 20 years, which, most commonly what happens when malloc fails. And at that point, your choices are give up and abort the computation and return a system exception or crash. And, obviously, in those cases.
Surely this should be integrated with the other error mechanisms. I mean, because you can presumably catch a system exception.
Yes, you catch them.
Yes, but you can't, at the point where malloc fails, you're not going to go around and generate a stack and do all this other fancy.
But presumably when malloc has failed and you generate a system exception, you're unwinding and getting back to safety.
Well,
in a good case, yes. Actually.
But you're but you're unwinding, right? You're back in safety after you've unwound, at which point you can no longer include the stack.
Oh, I get it. So there are many things you can't, many exception mechanisms that cannot be done for a system exception.
Right.
System exception is much blander. But I don't understand why it can't otherwise use the same mechanisms, but stack is missing, not available. Okay, so hold on. The right now, if you hit the iteration limit, which I don't really want to do here, what does it actually return?
Well, it's what you see right there. If you're running 13.
Well, nowadays it does, but it used to return a held expression, right?
Right. And you can get and for right now,
that's a bigger discussion to not return those held expressions.
It's slightly, I find it, we've had problems in our own code because we've had code that had a catch without a tag, and a catch without a tag doesn't catch this. So we looked for exceptions, we missed them because we didn't have the tag. And that's another issue is catch. You can't write a catch that'll catch tagless and tagged cat throws.
Well, you need a catch inside a catch, which is inconvenient, but not.
Or you could use the undocumented catch-all.
Let me
don't use catch.
Okay, let me understand what we're talking about here. So for 35 years, it has been the case that in a, if I do, and I hate doing this, but let me just do it anyway. If I say I feel like running a new version because I really don't want to crash this version, it's not going to crash it, is it?
No.
If I say x equals x plus 1, okay, that's what I get. I get a held expression back. Okay. Now you're proposing that in the new world, I would get a system exception instead of a held expression.
Yep.
Correct? That's a big change. That's a big change. There's tons of documentation of this. It's a big change. This
simple held example is a far cry from what shows up out in the wild, where recursions spawn inner recursions.
I know.
And a very common result is a crash or some mix of held and unheld or who knows what.
Right. I don't disagree. I'm not claiming what's happening now is great. I'm not claiming it's good.
Yeah.
Let me make a comment about this, which is that as we work towards this whole multi-computation business, one of the features of that is non-terminating computations. We are specifically, this is not the right time to do this, to make this change, in my view. We are a few months away from having a much more sentient model of what to do with non-terminating computations.
Okay, couple remarks. One, by tomorrow, I should have a pull request. We put this behind a system option. And by tomorrow, I should have a pull request ready that disables it going into 13.1. 2.
I don't care whether it's disabled. Hold on, Danny. If it's behind a system option, I don't think that will be a bad thing. We can experiment with it, but it certainly shouldn't be on by default.
No, it'll be off by default is what I'm saying.
Right now it's on by default. There is a system option, which is right now on by default. And Danny is saying it's right. Since it's just a default.
Yeah.
Okay.
But we can experiment with it.
Nonetheless, Stephen, you're going to find out in a few months that this is really a whole different world from whatever it is you think is going to happen with non-terminating computations. What this prevents is crashes from kernel stack exhaustion.
No, I understand that, and it's a good thing in that regard. But I want to make a unified treatment of the thing that is returned that represents what we know about a looping computation.
Well, that thing is going to be
What's that?
I think Danny is having internet issues. He warned us that might happen.
Are you not hearing me?
You cut out. You said that thing is, and then you went to.
I probably hit the mute by mistake. That thing is going to be a system option. A system exception, whether you call it that or not. That thing that gets returned in deep recursion or deep iteration.
No, I understand. And look, listen. I just feel like we are so close after all these years to actually having some kind of calculus of infinite computations that it will be a mistake to just go, cut it off right now. Let's just leave it for one version. Put this in behind a system.
Yeah, I'm fine with that. I was always fine with that. From my own point of view, I want to state it. I also think it would be a shame, given that we're so close to actually solving some of the many, many crash problems that we have, if this just disappears forever.
I don't want it to disappear forever. For 13.2 or whatever it is, this thing needs to be there. I just, this discussion, right? We are, the next step in evaluation graphs is the representation of the infinite evaluation graphs and so on. As soon as we have something reasonable to say there, you may be right that it has no relevance to the system exception business. I'm not convinced of that yet.
Okay.
Because what I'm hoping is the following: that a system exception, if we know it's an iteration limit or we know it's a recursion limit, that it is what am I trying to say? That it is we may have some representation, some minimized representation of a looping computation. And it might be very nice to return that instead of just saying system exception of quotes iteration limit. Okay, there may be a thing that is, the equivalent of that, but it is actually a computable infinite computation, a computable with thing where you can say it's like transfinite numbers, where you can combine two and you can do things like that, compare them, etc. That may not be impossible. Okay, anyway, that's my speech on the subject.
All right, before you go on.
Yeah.
Because, right, I wanted to first offer the comment that we've already discovered at least 5 or 6 bugs where infinite recursion was happening, but hiding behind the quiet. And with these system exceptions, we found them and fixed them. And now functions are faster because they're not wasting time.
You could at least, at a minimum, triple that number, Itai.
Okay.
That's great.
Yeah. The other thing is, right, I mean, there is the independent question of, do we want to document system exception for the case of malloc, or are we just keeping it undocumented for now and we'll decide its documentation fate at a later time?
We'll decide it for 13.2.
Okay.
As soon as we get, I mean, this has a timer. We definitely want this. I just feel like we are just a tiny bit early, and we want to understand infinite computations a slight bit more.
Okay.
Okay, because I feel like I just don't know how to represent some of these things, like the difference between an iteration limit and a recursion limit. Okay, one of them is a pure linear loop, and one of them is some kind of treeing thing.
Mm-hmm.
Do you believe that to be correct or not?
In principle, that is. In our actual internal implementation, I am not clear on what exactly causes the iteration limit in the most spectacular failure cases.
Okay.
It's never just a do loop.
Okay. Well, we need to look that up. I mean, we need to try and understand that. But
Yeah,
I think once we have
actually buried in the past, I'm afraid. I mean, maybe somebody here understands it.
I can't. No, I mean, I think if there's somebody who, well, maybe Rob is here and understands it, but I mean, I think this is a Tom.
I can't pretend I understand it. So.
Yeah. Okay. I mean,
Maybe
if there's
Tom.
anybody who understands it, it would be Tom and Mark.
Right. Okay. So back in the infinite past, I'm pretty sure that I implemented this originally.
Right.
And I'm sure I did it just as I just don't want it to crash. Let me do something here. Okay. And that was probably 1987.
We still don't want it to crash.
I know that, but I don't believe it's been thought about in the intervening, 35 years.
It has.
Yeah.
Oh, it has?
I made changes to recursion depth handling going back around 7 years ago, 8 years ago.
Okay, fine.
Which
All
improved,
right,
but it didn't fix all the
Let me
problems.
just explain one point, okay, about infinite computations. Just to see that there is a different types. There is I am an ordinal number, chunk, 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 I'm just going down this line, right? That is case number one. Then there is, so x equals x plus 1 is such a recursion, okay? X equals list x comma x is not. It's a different recursion. It's going to build, an infinite binary tree. Does that make sense? With an unknown, evaluation order, unknown foliation of the tree, so to speak.
Mm-hmm.
Okay. I claim those are two different types of things. And I don't know why it matters that they're different. And perhaps it doesn't. Although one of them notably uses memory and the other does not. Right? And there's some classification of these things which will be useful, I think. But I don't really know yet. And I don't know, in the world of transfinite numbers, for example, that tree-like creature is somehow a different number. Right? If you say how many elements are there in that thing? In the first example, it's just omega. How many is it in the second?
For the second?
What's that?
2 to the omega.
You think so?
For the binary branching tree?
Yeah. I mean, I would think it was 2 to the omega, but isn't that? Yeah. Okay. Well, fine. But then that's a different order.
Sure.
It's a different order of infinity. But we know, for example, we can, for example, as we combine. Anyway, it just requires thought, which we just don't have yet. So each of those data structures is going to correspond to some transfinite number, I claim. And finally, 150 years later or something, 140 years later, finally transfinite numbers might have a practical use. Anyway. Okay, let's move on here, I think. I mean, I think it's great that we're putting in the system exception thing, but let's not put it in by default, but let's run the tests and things with it and so on. Mm-hmm. Makes sense? Okay. Doesn't conjugate either vector. I haven't a clue. I don't know anything about cosine distance.
Okay. Right. So, I mean, right. So, right. Cosine distance is basically taking,
who's the expert here? Are you the expert? Who's the one who's really dug into this?
I volunteer Rob for that.
Thanks. I mean, I don't have any sense, what cosine distance is actually used for. I mean, my feeling on this is we need to make vector angle and cosine distance consistent.
Right, which I think is the opinion we've now converged on. Originally, there was some disagreement about whether we should. So there are in fact 5 different angles described in the literature for complex vectors.
Oh God.
Okay. And we use one of them for vector angle, and cosine distance should be consistent with that, is my position. And I think the others who initially disagreed have come along.
Oh, is this
to
a
that
breaking
position.
change?
I don't think anybody disagreed with the statement of consistency, Ty. It was just a question of which definition. But I think, and if cosine distance maybe can't use all the definitions, the vector whatever angle has to use something consistent with cosine distance.
Okay.
Yeah.
Right. And so
as for use, it's really useful for certain types of dendrogram type computations, but not I don't think anybody cares about complex values in that setting.
Right. So I mean, the one issue with the definition that is consistent with our current vector angle is that it gives a distance function which is not real.
Right. It's complex valued.
That's not good for distance functions. I mean, what other distance functions can be non-real valued?
That and correlation distance, which basically has the same definition.
Okay, can we find some, we need more expertise. The fact that you say you don't know what it's used for kind of disqualifies you, as far as I'm concerned, from having a real opinion about.
I kind of disagree with that. I think Rob, came up with something that's quite sensible here in terms of unifying the behavior and making them real valued so
you are claiming
as a metric.
You are claiming that you're going to make them real valued metric-like creatures, which I think is a good thing, and they obey then properties of metrics that metrics should obey. Is that true?
I think that's
even when you feed them complex vectors.
I don't know.
No, I don't think that's what Rob
No,
did.
a lot of these distance functions we have are not real metrics. So
no, I mean, you got, just take ordinary complex vectors. You take their inner product, you don't necessarily get a real value.
Sure.
It's when you take the inner product of the thing with itself, you do.
Yes.
Right.
So they're behaving more like inner product type beasts.
All right. So anyway, you've got a potential definition that you claim works for complex vectors. Has anybody asked Roger about this?
No.
Edmund on our live stream is suggesting a method option, which is not unreasonable. And certainly if we're making a breaking change, we should offer that. Okay, let's ask Roger. Let's make sure we have some understanding of the literature, which Roger is good at getting. Is there, for example, is it broken down between different fields, what people use?
Right. So in these definitions, right. So what one of these, the one that's called the Kähler angle, is depends only on the plane defined by the two vectors, for example. And so that one has applications to Kähler geometry, hence the name, the complex structure. The pseudo
angle. Is that different? Sorry, is that different from what Rob is proposing that we use?
Yes.
Then we got to have a method option because people are going to care about Kähler geometry.
Okay.
So how's that going to work in something like distance function, where you give the name of distance matrix, where you give the name of the metric?
You don't give its name, you give a function. So you can just say hash 1, hash 2, method arrow blah.
Yeah, fine.
I mean, it's an obscure case when you're changing the method. Seems to me like what we should do is try and inventory these methods and expect to have different ones and ask Roger for his take on the literature situation.
I hate to say it, but my experience with dendrogram, which does take distance function goes to cosine distance as an option, is it doesn't work anyway. So I think we have a bigger problem ahead of us, which is actually getting functions that should take distance, cosine distance to work at.
What do you mean it doesn't work? What do you mean by it doesn't work?
I mean, I get a slew of error messages and garbage output.
Well, then why? But why?
Do I know?
Okay, fine. So that's another thing
I'm
to
not
investigate.
familiar with the dendrogram code, and I have no idea what's behind it.
Okay, so fine. So, but I mean, you can see what arguments cosine distance is being given and see why it's complaining. Right?
Complaining because the code has bugs.
But which code? The code of cosine distance or the
No,
code of dendrogram?
Well, probably dendrogram.
Okay, but you don't know. And I mean, let's find out whether cosine distance is being given garbage or whether cosine distance itself is complaining. I mean, you know, clearly we can do this right now, but it doesn't seem like good use of our time right now. So it seems like this is not fully cooked. Go cook it.
Okay.
Okay, release versus development versions.
Right. So this is some email that was forwarded to me from Roger by somebody in your office that we should discuss. And I don't think there's anything to discuss, but I'm dutifully bringing up here with my argument about why there's nothing to discuss.
Okay, so the issue is the current release version versus what is in development. So the issue is if I just say dollar version here, okay, great. Now if I go to the prototype build.
Well, if you go to the prototype build, it'll say prototype version.
Okay, but the issue is.
But if you go to the nightly 13.1 build.
So your basic assertion is the following, that there exists a 13.1 build that was just made like any other 13.1 build, but suddenly it will be anointed.
Right.
Is that your basic claim? Yes. Okay. So I'm going to make the claim that it will be at least convenient for some purposes if, you know, if every non-anointed, I think this is a question for other people, should we in fact burn something in that says it's non-anointed until the moment when I see, you're saying
you can't.
We will have already done the test.
Right.
Okay.
Right. And it'll be code signed.
Okay.
And notarized with Apple.
Fine. Okay. Then I've got a different solution. Then I think the solution is we need a simple internal API that you can call to find out. So let's just make an API that we maintain from the build system where you can give it a release number and it will tell you whether it's a development build or not.
Yeah, I don't know what it is, but I'm pretty sure that exists. And if you just ask Pat Rice, he will.
Okay, so fine, but then let's put that in the internal function repository, and then we're done.
Okay.
Okay, that's a better solution probably.
Yep.
It might have other comments about it. You know, maybe it even has comments about what the status of that build is, and those kinds of things. Okay, let's talk about Lambda for a second.
Right.
So yeah, go ahead.
Yeah, so I'll just point out that, you know, I'm not exactly sure where this discussion originated. So not everyone here, in fact, I'm not entirely sure where it is we're coming from or what we're trying to accomplish. I do have the comment that if we're going to add yet another form for function, it probably should be a matchfix operator. Otherwise, you know, you'll always get complaints about precedences, but.
Interesting. I do agree that, yeah, match fixing somehow would be nice. Okay, can we imagine a way that Lambda could be a match fix operator? Could we imagine a stylized Lambda that could be somehow made match fix? Let's go back to old mathematical logic.
Okay.
You know, let's go back to, gosh, I must have this somewhere. Well, let's just see. I just got Alonzo Church's collected works, but it's as a physical book. I had no idea that Alonzo Church had written about so many things about which one doesn't remember that he wrote about them, and they were very unremarkable, which puts his work on lambda calculus into a. Okay, let's just see whether we can find this here.
Well, you know, he was also in the right place at the right time, right? He was at IAS with
He was at
Turing. So
no, Turing was no, that's not correct. Turing was actually a graduate student with him, bizarrely. I mean, that is, Turing went to, supposedly Alonzo Church was Alan Turing's thesis advisor, but Alan Turing had already done his, okay, here we go. Lambda definability. Lambda. Okay, that's what, okay, so what he used was lambda AB dot blah, blah, blah. Notably not delimited.
right.
But now what happens when he applies the lambda to something? Oh boy, look at that creature. He's putting a brace around the lambda and then applying it.
Mm-hmm.
Not beautiful.
And the dot disappeared somehow.
Well, but look at this craziness. Look at this absolute frigging craziness. I mean, we can't really, fault them. It was 1935 and they didn't really understand a lot of these kinds of things. But look at this. This is a nested lambda,
right?
In which I can't even read this thing. What the heck is this? Where is that C? Is that C?
Right. So that's the local variable, right? So it's a function that takes A and returns a or no,
yeah. So, but no, I think what happened here is that the parentheses are a mess.
Mm-hmm.
So he doesn't have I've never seen a back end delimiter for lambdas. Let's see. Okay, this is not relevant. The notion of effective calculability. Okay. Oh, that's an exotic. What the heck is that creature? Oh, we went German here. We went Gothic. Well, as Alan Turing used to call them, German letters instead of Greek letters. What is that letter anyway?
Is that a Q maybe?
Oh. Edmund is asking, can Lambda be use a template box for its body so brackets are not needed? Yes, but the question is, what we really like is an ASCII form of the whole thing. So you can type it in. So you can type in a function in a delimited way. What would be a natural way of delimiting it? I mean, here, rather crazily, he's using braces around the lambda. Just for, I mean, that's the basic, so he's outer delimiting it, so to speak. And he's got this very exotic critter.
Well, is that a function or is that an embedding of some kind? If F is lambda definable by formula F.
Okay, let's see if there's anything else here. This is just crazy. I mean, look, it doesn't help. Like Whitehead and Russell had used dots instead of parentheses for delimiting, which was completely bonkers.
Mm-hmm. Right. I'm starting to feel like I'm reading Lisp code.
Yeah, well.
I mean, obviously it's not S expressions, but it's.
I know, and who said this? Somebody, maybe Dennis Scott, maybe somebody claimed that John McCarthy had never actually understood lambdas, which casts the whole Lisp thing into even more confusing. Okay. Richard is commenting, it's as if he was trying to use operator forms with those braces. Yes, arguably. Okay, so the question for us is, clearly the form lambda sub whatever of whatever is interesting. I mean, it's a nice, that's a perfectly nice thing. It's not clear that that's of great advantage. I mean, the main problem,
given that we have pipe dash greater, I don't see the advantage of that, but over what we already have.
I admit that this is a pretty nice form, that one there.
Mm-hmm.
But the real problem that we have with this one is the lack of, is the very annoying thing that we have to go church style, so to speak, and do that to apply it.
Right. I mean, the precedent is set up so that, if you assign that pure function to a variable, then you don't need any parentheses.
Yeah, but look, I mean, the difficulty is that almost anything could come on the right-hand side, including plus signs, equality, exactly. All kinds of things. Yeah. Right? So the only question is whether there's a way. I mean, I guess I don't usually do it this way, but I guess you could do this, right? You could say x squared plus 1 like that. And then if I said of this, no, I'm toast.
Yeah.
So that's pretty annoying that to apply the function, I basically have to, I mean, clearly if I'm inside a map, I don't need any of that stuff.
Right. So if you had slash at, I think, well, no, the slash at might still be right.
I think the slash at gets captured. I mean, I don't.
Yeah, I think it does.
I mean, if I say this, if I've actually got delimited arguments, I'm in great shape.
Yep.
And that's beautiful. The issue is how to apply that. I don't know any form of application. I mean, this might just be an idiom.
Right. And the problem is that both at, slash at, and especially bracket have very high precedences, right? So if you made it high enough that you wouldn't need it around those, you'd basically always need to parenthesize the right-hand side.
Right, but you never can do, there's no operator. What the heck could you do here? Other than something matchfix. And so the challenge then, is there a tolerable, what would you do? I mean, with a lambda, how would you end the lambda? Is there any reasonable way to end the lambda? Our friend Alonso has not helped us here.
Yeah. Well, I was going to say, I'm not sure I actually like the suggestion I'm about to make, but vertical bar is sort of some variant of vertical bar is the least bad idea I've had thus far.
Yeah, but you see, what the question is there any way? Well, okay, actually, there is a difference here. Look, if we had this, okay, at the very least, that could work in a way that, I don't know whether we care, but that could work precedence-wise.
Right. If that lambda has a higher precedence than bracket.
Yeah.
Which means you would always have to use parentheses.
Oh gosh.
Right. It's the pattern test problem all over again.
Yeah. Well, then, right. I mean, then the other possibility would be, okay, here's a weird idea. No, we can't do this. I was going to say, if there was an operator form of function where a special lambda actually just stood for function, so you could write lambda instead, just like you can write, pi instead of writing pi.
Mm-hmm.
I don't think it really helps you because you can't subscript unless we could make the syntax, but it's not going to help you. It's not going to help you because you still have to delimit the body. Right, I think I need to run off here, but to be continued. We're going to come back to this. Are there any other conventions for lambdas? Languages that have a lambda, like Haskell, for example, how do they delimit the end of the lambda? Anybody know here?
I think we need Christopher, somebody who's more of a language.
Fine. Well, let's try to do this.
It's like it's just a backslash.
No, I understand that. That's the front. How does it delimit the? Oh, it has a weird parser, right? It has some kind of left to right parser for everything. We need Christopher. He knows about this stuff.
Okay.
All right. Good stuff. Thanks a lot, guys. Thanks to folks on live stream too, and see you another time.